Hey everybody, this is Larry. This is me doing Retro Biweekly Contest 72 on Leetcode. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think. So today I'm still in Cartagena, here in Colombia, the country. I don't know. So I missed this earlier today, but I am here to try to do this now. Again, I don't have a bed, so I'm doing it. Oh, sorry, I don't have a table, so I'm doing it from bed. Am I ready? I guess I'm as ready as I'm gonna go. Just if you want to know what's up, just join the Discord channel. There are a lot of smart people there, even when on days where I'm traveling, I'm not there. But yeah, and I always respect them. Okay, cool. Yeah, with that out of the way, let's get started. I'm gonna scroll down slowly so I could go to the virtual contest button without seeing the problem names because sometimes they're hidden giveaway. Okay, am I good? Am I good? Okay, lap. I'm on my bed. It's sitting on my lap. I'm ready to go. Let's. Okay, am I ready? Yeah, let's go, 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 go. Let's go. Okay. Do. I is equal to J. Oh, and I times J. Okay. Well, I mean, that's fine. This is a weird problem, for sure. I plus 1. If just this, and num sub I is equal to num sub J, then what happens? Just count. What's the answer? Is 4 and 0? Oh no. Pay to win. Give us submit. Okay, let's go. Number 2. Find 3 consecutive integers that sum to a given number. Okay. I don't know if this is good enough though, right? Let's see. I mean, if number. Can it be negative numbers? Huh. I guess negative numbers is fine, but still. I mean, this seems pretty. I don't know. I hope I don't make some silly mistake, but that's pretty silly actually. Okay. Maximum split of positive even integers. What does that mean? Unique positive even integers. Okay. Okay. This seems like just brute force, right? Yeah. Okay. 10 to the 10. So we're just gonna do a square root of this. So that's fine, I think. Let's see. Okay. So if it's a even number, it's always possible because it could just be by itself, right? So then here, final sum is equal to 1, return, otherwise, it's at least a 2, then, okay. Yeah, okay, I think I got this. This is at least a 2. Oh, yeah, whatever. You could probably be smart about this, but that's fine. Okay, if length of answer is Let's see. So the last one is okay. I think this is actually good. Maybe. Let's see. 2, 4, 14. I mean, wait, what? That's not right. Oh, what I want is actually. No, this is the final sum. Is what I meant. Okay, 2 or 6, 2. Okay, I think that's good. I'm a little bit rushing a little bit, maybe. Maybe I should take. Okay, maybe not. That's fine. Okay, I can't go triplets in a array. So, numbers. Three distinct values in which increasing order by both. Okay. So in this case, I'll say what? 2, 0, 1. What does that mean? Just the first index. Okay. Yeah, that's right. Oh, 1, 3. I don't understand this, so let's read it again. I don't know what this notation is. Okay. Index of value right in number. Okay. Okay. So then 0, 1, 3 and 0, 1, 3. Okay. So is this his longest? Oh no, I was gonna say longest increasing sequence, but I think this is just DP with 3 or something like that. Something weird. Excuse me. So 403 and 403 is in the same order. Okay. Let's see. Yeah, I think this is just DP on the 3 thingies, right? You start with the 4, there's 0, you build off. Okay. I have to try to figure out how to write this in a good way. I mean, this is odd. I feel like people are very good about this, but okay. Is there fireworks going on outside? Something? I don't know. I think there is fireworks outside. I'm missing some fireworks, so I hope you appreciate it. But okay. How do I want to do it? Okay. Maybe I'm not doing this right. Okay, so 4. How am I phrasing this? So we go index 1. Am I thinking this way? Maybe I'm just hand wavy a little bit. So 4, we know that it is the, yeah. Well, at least like what I think I am trying to do is maybe n square. So maybe that part is wrong. So now we can go to the 1 and it's not necessarily, but let's see. Let me think. Okay, so let's say we go to 0, right? 0, we mark to 0. And then here we have 2 and 3. And 2, we say, what's the common preset of 2, right? Well, 2 can have, okay. How do I do this in a good way? Okay. So let's say we do top 4 is equal to, I still feel like it's DP, but I'm not doing it quite right. Or like, you know, like 3 level DP or something like that. 4, you look up to 4, and the other 4, right? And let's say with 0, we look up to 0. What does that mean? That means that I think the part that I'm struggling a little bit is try to figure out how to do it in linear, or maybe n log n, maybe say. Basically, you have some like longest increasing or longest common subsequence of length 3 or something like that, right? And LCS is obviously very big. Well, not longest, but the number of common subsequence, and that's like a very trivial n-square solution actually for dynamic programming. But now we're trying to figure out how to do it in not n-square, right? Okay, let's see. How can we look this up, right? So let's say we're going from left to right. How do we pre-process this? Let's say that we have 0. We match the 0 here. Okay, that's fine. How do we process the pre-things? Okay, let's say 4. Let's start 4. 4, what does that mean? So 4, we have no prefix, so here's the 4, right? Okay. So then, what does the O mean? O means that, okay. And then we know that the previous number, 1 already exists. I feel like there's a count way of doing it, but. And then at the 1, this one, and we basically do a set intersection. But that's still going to be n squared because I'm not being careful. And also, when we get to the 2, we have to be able to figure out the 2 paths to it, right? Maybe I'm thinking about it in a stupid way. Let's see. These are permutations. Does that mean anything? I mean, going backwards is the same, right? So I don't think there's anything there, but 0, 1, let's see. Can I do anything sliding? Don't have a great answer for this one yet. Maybe this isn't right. Let's see. Let's see. Wow, I'm really bad at this today. So okay, so let's say we pre-process it like almost like a breadth-first search. How would that go? So 4, we go do 1, we do and 1, we know that there's a 4. I don't know. I don't think that's the way to do it though. Yeah, I don't know. I'm gonna. Wow. A lot of people already finished. So that, wow, 6 minutes. Jeepers. I mean, I thought I was fast. I mean, I would have been if I finished Q4 in 3 minutes, I guess. But that is ridiculous. Okay. Oh, and good job, Josh. Where am I? Oh, I'm 18. So I'm actually doing pretty okay in the fake rankings. Considering a lot of these people also did Q4, right? but I don't know how to do it. Let's see. All right, let me see if I could think about this in a better way. If they're both exactly the same, then I guess you just n choose 3. So the worst case answer is gonna be n choose 3, right? Which is, you know, n to the cube over 6 or something like that, but that's not gonna be fast enough. There's no way. I guess the question is, can I sort one in the order of the other, and then it becomes easy, right? Like here, then we already know that if we sort at numbers 1 instead of numbers 2, then here you just have to look at the number of increasing subsequence, right? And that should be okay, maybe. Yeah, maybe that's it. Okay, let's try that. I still have the idea still shaky in my mind actually, but here you just have to do the number of increasing subsequence of 3. Can I figure how do I do that again? Of a binary search. Is that really right? Because then you have 2, okay, and then 0. And 1, what does 1 mean? 1 means that, okay, that's the number of smaller numbers that previously before, which is 0. How do I do this? I think I have an idea now though, at least. So then here we can sort, yeah, let's just say, what's it called? Sort this. So enumerate between I and X. So we sort it by, whatever. So T of, so T of 0 is the I, and then you have numbers of 2 of that. Okay, I think this is right, maybe. And then yeah, okay, let's just print it out. Let's see if that works. Okay, so that does seem like it's working because this is returning 2013 because it didn't change, and here it's running 10324. Okay, and then now we have to get the number of increasing of length 3, which is 024, 124, which is 2. Is that the answer? What's the other 4? And then 034, 024, right? So that's 4. Yeah, okay. So I think I'm more confident now of this idea, but yeah. Okay. Right. Okay, so then now we have to get the number of, and of course that, I mean, that still has an n squared solution in the naive case. I forgot how to do it in, I mean, I know how to do, well, that's the longest, not the increasing subsequent, right? So here, okay, let's say I have to maybe, I think the smarter people will be able to get this, so that's why, but okay. So we start with 1, we go to 0, we start with 1, so length 0, okay. And then 0, we go, okay, there's no smaller numbers, so, yeah. Then 0 has, okay, let me play around with some ideas. Okay, so as equals sorted list, say for x in nums 1, we go, okay, so we now try to count the number of smaller numbers. Does that make sense? I mean, it makes sense for being the first number, but then now we have to get the second number, and we have to get the sum of all those things. Is there an easy way to get the prefix sum of all that stuff? I don't know. Like for example, we want to get the third number. How do you get the third number? So here for some for 4, we have to see that 4 small number exists. So that one is easy to forget one number before that. And 4 has, I guess, 4 numbers behind it. But then now we have to get the sum of all the other things. Do I need a binaries index tree? Maybe that's how. Because basically 0, you have 0 numbers, and then binary index tree, I put a 2 before. So now you could do 4. At 4, there's 4 numbers before. 2, there's 1, 2. So then the 2 had 2, and okay, well maybe do another way. 3 has 2 numbers before. So if 3 is the second number, it would have 2 paths, right? And then when you get to 4, you just go, okay, well 2 has 2 paths, 3 you have 2 paths, and then here 4 you go, okay, there's just yeah. Okay, I think I'm convinced, but I'm always a little bit weak on binary index trees, so let's yeah, okay. Let me figure out. I'm just trying to find my old code. On the side, I used to be able to Google my old code and it shows up. Man, wow, it really dropped off to yeah. Jeebus. Why is it that I don't get it, but okay, fine. Okay. So then now, okay. So the sorted list will allow us to get how many numbers that are 1, right? So this is going to be a little bit tricky, so bear with me. Because I don't know how to do it myself, or like, you know, I'm trying to think about it myself. Okay, so then let's do the first 4, whatever. Okay, and then increase of index delta. What do we do? I should. Okay, fine. I feel like I should. Yeah. Well, text is in length of 3. That's afterwards. It's been a while since I remember this, so I don't know. Let's just go total. Text plus 1. Okay, there we go. Right. And then here basically is saying, well, we're going to add x later. Smaller is equal to SL dot bisect rate of x. Well, x doesn't show up anyway, so it doesn't really matter. And then we increase x with smaller. That will give us so this gives us the numbers that have 2 things, and then now maybe something like this. Yeah. Okay, I forgot it again. I think I did it recently as well. But I'm focused on the other part, obviously. This is the relatively easy part. 1 and 4. All right, let's give it a submit. I don't know if this is right, but it's fun enough to give a submit. Oh, Okay, so I'm really wrong. That's a little bit unfortunate, actually. How many people got it so far now? Well, a lot of people got it, so I'm really sad. Why do I? So knowing that my answer is worse than the expected answer is kind of sad because then now, um, maybe I don't have any idea then. Okay, so we have this thing. Let's see. I was just double checking whether it's a small index or whatever, but. So the smaller is the number of ones, okay. Total X is prefix, right? Did I mess that up? I think there's two, I think I sometimes mix it up to, yeah, no, I think this is right, but, or like my implementation of what I expect, but, yeah. I mean, X doesn't show up yet, so I think it technically is X minus 1 inclusive, but, So 0, 0, yep, 0, 5, and maybe I should print out X as well. Okay, so 5, there's 0 numbers before, that's fine. Smallest 1 number smaller, yep, and then answer 0, I guess that's fine. 15, there's 1 answer, that's true. 0, there's still only 1 answer, that's true. 4, 4 has 2 smaller numbers. Right, yeah. Am I miscalculating it? Maybe. 2, we still don't have another answer, because, okay. But I think like this reduction is right. I'm just messing it up. 6 when it comes to 12 because let's see if that's right. Let's see. It's such a mess. Okay, well we can do something about that because here, if this form is equivalent, we should have. Oh snap! Oh no, that's the input. If the form is equivalent, then this number should. Yeah, that's 1, 2, 3, 0. Oh. Is there a 16 here? I can't find. Oh, I just missed the 1. That's an odd thing to miss. Okay, so I think this reduction is right to this thing, but my thing is clearly wrong. Okay, but then now that means that I can reduce this to maybe not, or like not easily. That's annoying though. Okay. Now we can say, well, at least like it has the same reduction. I don't know. Maybe that's just wrong. Actually, I can say that is right. Let's say up to the 12th. So the first. I don't know. Do it again. So nope. Oh no. Okay. But this one, I'm getting. Of course, it's not variable, but maybe I translated this wrong actually. Oh yeah, I missed the number. 5. Oh, this is 6. I guess. I thought there was 6 numbers or 7 numbers. Okay, so this is 6, same as here. I actually don't know what the expected answer is. I thought I would get it, but okay. So we have an equivalent one. 6, does this make sense? Is 6. Yeah, 0 2 5 is 1, so 3 5. Well, 1 4 6 is obviously 1 1 3 5 1 2 5. So that's 2. Okay, so how many contributions are there from the 2? 2 contributes 2 from no, just 2 from 1 1 from 0. Okay, so 2 is 2. I don't know what I'm doing here. Okay, I'm just not doing well. Okay, fine. I can also do the brute force one to get the answer as well, to be honest. But okay. Then here 16 is the really weird one, or maybe not. I don't know. Okay, let me do the n square solution. I think that's what I would do to double check my answers. Nope. This isn't right, but so actually what we want is okay. Okay, so what does this give me as an answer? I guess all the sum of the last one is what I want. Yeah, okay. I still print out 87. So maybe maybe there is something wrong with my reduction then, and that my math is right, but the reduction is wrong. Okay, maybe that's why. I thought that this reduction is good, but I seem to be wrong. Let's just do it here. It's still printing 87. Am I misunderstanding this problem? Oh no, this is not that brute force. I guess this is the brute force on. So this is checking this part, but it's not checking on the reduction part. Okay, so maybe my reduction is wrong. Yeah, whatever, why not? We're using infinite space. Okay. Maybe I'm just being a dummy. No, that still ends. Okay. This actually may be wrong. It might overcount. Well, I guess my reduction is just wrong, and also this is overcounting by a lot. Maybe I don't know how to do DP. Okay. Well, this is yikes. I thought that this reduction would be right, to be honest, but clearly it's not. No, is it though? I'm just sorting it wrong. Let's see, what's the input? So input is 0. Wait, maybe I'm just doing it wrong. Okay, so this is the input. Well, this input, we'll look at this input. Okay, fine. This is the input, right? And we sort by the second one. Maybe I have to sort by the reverse of the second one. Maybe I messed that up. Maybe that's it. I didn't check that tight enough. Because 0 means that the first number is 1. Okay, 1 is 5. Okay, but maybe it's a variation of this. I'm doing it wrong. Because I think 13. Maybe that's what I'm doing wrong. Is it though? This is very weird. Because I don't think this makes sense as a transformation of this. Because 13 is a very big number, right? And that doesn't make sense that, that it would reduce to a 1 even if you do it in some funky way. Maybe I just didn't audit it that well. It is something like this, but I'm just getting it wrong. Because, okay, so if this is this, then that's fine. So what we want to do is we want to... I think this logic made sense, but I think, or this observation is something that makes sense, but I think I'm doing something funky, because you cannot just sort the second one, and I think that's what I'm doing, and that's why this is wrong. But it's something like that, which is why people are able to get it this quickly. Maybe, I don't know. Yeah. So 13, how do we map this 13 to something that we can use? Right, because the increasing part, it's not just matching, right? It's not longest common, it's longest increasing. So I think that's where I messed up, because I converted the 13 to 1 for some reason, which obviously doesn't really make sense, because this 1 maps to this one, which doesn't have even the same thing. I'm really messed up here, so I definitely didn't really check my thing. I think this part is still reasonable if we can run into 1 away. I don't know how to do that yet though. So how do you do? Okay, so this is 13. Oh, it doesn't have to be. Oh, I'm wrong again. I think I mixed it up. It's increasing order in the second array. So the 13, I think I just need to sort by the reverse word one or something like that. Because the 13 is actually instead of 1, we need to look at the index of the second one. Okay, I think I just messed up. I confused myself. I think I used the other mapping or something like that. Okay, let's. Also, I think I just tried too hard to make it one liner. So let's go. Okay. Nums2, lookup of x is equal to I. Okay. And then now we go, okay, I think this is just lookup. Okay, let's run it real quick. This is enumerate. Okay. Wow, I am just, okay. I mean, I was close maybe, but a little bit sloppy in the thought process. Okay, so this is still the wrong answer. But let's see if that actually makes a little bit more sense at least. So the 13, is that this one? Okay, so something's still a little bit wrong because 13 is not the 15th index. 1, 2. So I need to replace this. I think I'm just still sorting for some reason, but I have to actually replace this with the index of the other thing. So what I want is actually not a sort, but a lookup of x for x in nums1. Okay, there we go. I am just being silly. Yeah, okay, well, give it a submit real quick. Hopefully it doesn't time out. Yep, oh man. I am, that was not a bad one, but I was very silly. Oh well, I mean, it's fine, I guess. What does that put me on rank? 132, is that the thingy? I don't know why I just assumed it was right. I think I just didn't look at it and sanity check. Oh well. Yeah, I mean, I think that's, I want to say that's pretty much all I have for this one, this contest. Let me know what you think. I'm still in oh no, I'm not. I'm in Cartagena. Yeah, I look forward to see y'all soon. Yeah. Stay good, stay healthy, to good mental health, and I will see you later. Bye bye.